Hi everyone, this is a lesson 28 for the Arduino 4-digit 7-segment display. It's really kind of nifty, but we'll get on the backdrop here. Instead of using a 1-digit 7-segment display, I'll show you that. Where are you? There you are. We did this last week. See that, everybody? This is 1-digit 7-segment. We're using a 4-digit 7-segment display instead. This here. Okay. Now, if it's a common anode, use a pin to the power source. But if it's a common cathode, cathode connects to the ground. So it's just a different hookup. It's still connected to a power and a ground. In this case, it's connected to two separate grounds at the resistors and at the 74HC95 chip. It operates on something that you may have heard of. Last time I heard of it was with a 321 contact with a slew thing they had back in the 70s. But persistence division is it's going so fast you barely notice it, and it forms the numbers and letters that you see on your 7-segment display. So you can see these better than you did last week with the other display. My camera is working much better. It's showing different numbers and symbols. It's and I'll explain how that's going. That's still going on the clock, and it's got a clock, a latch, and a data that gets sent. And when those all hit the same bump, you could say, in the waveform, let's say they hit a low versus a high, that's what turns on the lights. And it goes on the timing. And that's how, but the data is sending in, and that's what's forming your letters and your numbers and everything. That's the best way I can explain. And that makes sense to me if I say it that way. Okay. So I'm scrolling down. They have the measurements. So why this is probably important, I've given a lot of thought of this. If I'm designing a circuit and I only have so much room on the circuit board and I want it to fit within my design, I want to know the dimensions. So this goes into this. I don't know if you can get smaller. Well, I'm almost sure you can get smaller displays than this, but it's good to know. And the 5643A, I think that's for the anode when you're connecting to the power. For one type, and to make it a cathode, the 5643B is for the cathode. These numbers on top side on each one connect to your bus, the blue wires. So remember the blue wires. I'll be coming back to that. These go to your different data legs, your pulse wave modulation, I believe. Let's look at the display here. Okay, here's your blue wire. It's connected to the 220 ohm resistor. That dictates, since this is a cathode going on the negative, it dictates what lights turn on and at what times and so forth. And we'll follow that all the way to your output enable and your ground here. That's how I know this is a cathode. If it was hooked up to your power, your VCC up here, or your MR, it would be a whole different story. It is not. So that's why I say that. And your data lines here, here they are. Here's 0. I hate to say data lines, but pulse wave modulation, maybe I can say that. No, I can't even say that. But they connect directly to each of your segment displays, forming the different letters and numbers. And the wires connect to different segments throughout the circuit. But here there's not as many. There's 1, 2, 3, 4, 5, 6, no, not 6, 7, and 10. Those are the only ones hooked up on that. And your clock, your latch, and your data, which is what dictates how they keep switching like that, they all connect here on your Arduino. And here's a rough wiring. And this is the blue bus, which goes to the ground, which dictates the order they go on from where they under. And it also makes it a cathode. That's how we know it's a cathode. And I think that's about all of it on this lab. Oh, yeah, I'm supposed to upload the 28 file to get it going and confirm it. I had to update my library too. And here's a rough copy of the wiring diagram. And you can see the blue wires going to ground here because it's on the same strip here and goes right to ground. And then there's a separate ground. They both go here. You just have to trust me for it. And your data lines, your clock, your clock, your latch, and your data all go here on this side of the chip. And then you have the different legs going, the different addresses, I guess, going to each side of the display, lighting it. And then they come out again to these resistors. Then they all connect here, which goes into a single connection to ground up here. And I'll prove it to you. I'll move up so you can see it. Okay, you saw it. So there. Okay, going onward here. Let's look at the circuit. Okay, here it specifies where it's being hooked with your latch, your clock, your data. That's controlling everything. And it's showing output for your latch, your clock output, data output. Okay, I'm just going down here. And it's showing each display for numbers here, and the delay looks like 500. It must be microseconds or milliseconds. It's probably milliseconds because microseconds is just too long. But it looks like it displays all those. But it looks like it's showing FFFF, and I don't expect you to know that, but it could be another way of saying a hexadecimal type of counting, because you're used to your 1, 2, 3, 4, 5, 6, 7, 8, or counting to by 5s, 10s, 2s, whatever. But there's also a coding by hexadecimal and binary and what 1s and 0s. So that's probably what's going on there with those odd numbers. Okay, that's all I've got. So you have a good day, you be safe, and make the world a better place where you can in your own world, okay? Take care. Bye.